Hello everyone, in this particular session I am going to discuss about implementation of PCA in Python with scikit-learn library. So PCA is basically converting the high dimensional dataset into some lower dimensional dataset without losing in information. So basically if we read this definition, so what you can see is principal component analysis or PCA is a statistical technique to convert high dimensional data to low dimensional data by selecting the most important features that capture the maximum information about the dataset. So to implement this PCA, so first of all what I have done is I import the pandas library to do the operations, various operations related to the data frames, and after that I define this URL. Basically I'm going to use that iris dataset, which basically contains 4 numerical attributes and 1 target attributes. So here I have defined the link as URL, and after that I read the dataset directly from the URL. So here I have pasted the URL inside that pd.readcsv, and these are the names of all the attributes. That is sepal length, sepal width, petal length, petal width, and the target variable. So after retrieving, means after executing this particular command, we can see like if the display the df, we can get sepal length, sepal width, petal length, petal width, and the target variable. The data frames comes here, and here if we observe, we can see like 4 attributes from the dataset are numerical in nature and the target is categorical in nature. So based on these 4 attributes, if we observe, based on these 4 attributes, we need to categorize the target. So before going to PCA, first we need to do the standard scaling of the dataset. So standard scaler is basically a library which reduce the values of the attributes from higher ends to the lower ends. I mean that to a standard scalar ends. So here the numerical values are these 4 attributes are numerical. So what I have done is I consider those as features, and after that I separate the dependent and independent. So here I can see like x equal to df locations, all the features values, and y equal to df locations, the target features values. So after separating, I can standardize the values of this all those x, that means all those numericals, this numericals values. So I have assigned x equal to standard scalar fit transform x. That means it will convert all those higher range values into some lower range, that means into some standard range values. So after converting those values into some standard range, what I can do is I can use those values into the PCA algorithm. So for using PCA, what we need to do is we need to import that sklearn decomposition PCA library, and here I have defined n components as 2. So here n components as 2, and that means we are going to reduce the components number to 2, and the principal components, after that I define as principal components equal to PCA.fit transform, and giving x as the input, and it converts all those standard 4 attributes into the principal components. That means the 2 components. So after that I have defined as a principal data frame as pd.dataframe. Data will be that components, and the columns name will be principal component 1 and the principal component 2. So after the final definition, final data frame will be the principal components, that means the principal data frame plus the target variable. So after executing this particular step, if we observe, we can get like final data frame will be final df, it will contain the principal component 1, principal component 2, and the target variable. So by observing this, what we can say is like from those 4 attributes that represent the sepal length, sepal width, petal length, and petal width, we have reduced those 4 attributes into 2 attributes. That means we did principal component analysis by doing or by converting the high dimensional data set into some lower dimensional data set. So after converting this those four attributes into two components, what we can do some visualization on that. So here I have imported that matplotlib pplot as plt, and I drawn the scatter plot for that, like principal component 1 and the principal component 2. And finally, if you observe, you can see like these are the components that are present in the second principal components, and these are the values which are present in the first principal component. So this is all about principal component analysis. So from this we get to know like how we can reduce the dimensions of a particular data set, like high dimensional data set, into some lower dimensional data set without losing any important information of the data set.